Okay, so on this guy here, we have a conic question mixed with a functions question as well. So I've got a square root function here, I've got a circle, and I have an ellipse, and then we have this sort of line segment right there. So let's read through what we've been given. A graphic artist created a design to be placed on new branded chocolates. It has an ellipse, a circle, and a square root function. So that's how I knew this was a square root function. I could kind of assume it is just based on my previous encounters, but it's nice that it labels it and tells me that that's what it is. The ellipse has a major horizontal axis of 20 units. So major horizontal. Based on the way this looks, okay, we can safely assume that they're telling me that that is 20, and then they said that the minor axis is 16. So that's the information I've been given so far. Okay?
So basically you know your A and your B.
I know my A and my B right off the bat. Okay? The ellipse is centered at 10 and 8. Okay, so I can put that down and say 10 and 8. That makes sense. Okay? Should be more in line with the foci. Okay? So, and the equation of the circle, so the circle is this ugliness right here. Okay. Vertex of the square root function coincides with the foci of the ellipse. So that is going to be, okay. So I have that as a circle. I'm just going to kind of list what we have here. We know that's the foci of the ellipse. We know that this square root function passes through the center of that circle. My drawing doesn't do it justice, but that's supposed to be the center of the circle, so that's my H and K. So you can even write that on that document, right? Right? The center of the circle, underneath center, you can write HK. Point S is on the square root function and has a y coordinate of 875. So I don't know x, but y is 875. All right. So it seems like I need to find out what that x value is there. Point P is on the ellipse. So that's on the boundary of the ellipse. It is located 3r horizontal units to the right of point S, where r is the length of the circle's radius.
Are we serious?
Yeah, this is a pretty intense one. Yeah. So what I would do originally on something like this would be to kind of work my way backwards to go like, what the heck am I actually looking for? Okay? So it's saying we've got to find out what point P is. Okay? Now, all I know right now, okay, is that P, okay, is on this line segment right here. If I can figure out what this S value is, I'm going to use red here. If I can figure out what this S value is right there, and I can figure out what this radius is right there, then I'll be able to get the X value of point P. And then as soon as I get the X value for point P, well, I'll be able to plug it into the rule of this guy, because Cade, you've already pointed it out, that my A is 10 and my B is 8. So without even thinking right off the bat, for the ellipse, very little work involved in this.
You highlight it, right?
X minus 10 squared over 100 plus y minus 8 squared over 64 is equal to 1. How do I know that? Because when I list for the ellipse here, my A, B, C's, the rule I don't need the C value. I'm going to need it at some point because it's part of this question here, right, that I have to solve for. But right now, if I know that A is 10 and B is 8, and I know the H and K, which is the center of this guy, is 10 and 8, then I can write out the rule of this ellipse. Okay? So I'm just going to download everything I know right now, and I'll just backtrack again. With all the information I've been given, I was able to easily figure out this guy here. My objective is to find point P. I know that point P is like an x and a y value. That x, how am I going to find it? I know nothing about it right now. It's just in the middle of space. I know that it is 3 times the length of the radius away from the x of this guy, which I don't have, which means I'm going to need to find the rule of the square root function. How am I going to find the rule of the square root function? I'm going to need 2 things. So I'm going to put this. So you really, I find like this guy here, you got to work backwards a bit. I'm just going to move over for a second and say, we're going to approach this guy first, but in terms of the key to this is the square root function, okay, and finding the rule of it. So I've got to find the rule of this guy, okay? How do I find a rule? Well, I need my h and my k. I need 1 point so that I can go ahead and use that to find out what the a is. Then I'll be able to use that rule later on. Okay, so if that's my objective, I need to find the hk of this square root function, which is also the foci of this ellipse. So what I'm even going to do is, right next to this guy here, what the heck is the hk of this guy? It's foci. In fact, it's the right foci. Right foci of ellipse. You don't have to write this stuff out. This is just me telling you what, like, my mental process right now of how I would approach this guy. Okay? And the xy, well, that one is just the center of the circle. Okay? Center of the circle. So we now have kind of what we have to find before we can kind of go in and get started. I can't find the rule until I get the hk of this guy and xy. I can't get the hk until I get the foci of the ellipse. I can't get a point on that square root function until I find the center of the circle. Okay, so those are all the things that I'm thinking about as I'm approaching this guy.
God, there's so much that you need for everything. It's like,
yeah, so like
unlocking different.
Yeah, so like, do you like? Did I do, or do you have any questions in terms of like how I would work backwards, or is there anything unclear in terms of how I work backwards to get what it is that I need to know to kind of fill things out? Like, I'm going to just pause this for a second. It was good. I liked all that. That I wish I had that recorded. I just wanted you to talk more. So the ellipse is a great place to start. It's where we started. The other thing too is if you were given a question like this and you saw a guy like that, the first thing I'd want you to do is rearrange him, right? Like if I see that without even thinking about all of this nonsense here, I would at least go ahead and say, well, I can at least get that in a form that's going to be valuable to me, because it mentions somewhere in there that 3 times the radius of the circle is going to be something that I obviously need to know. So I might as well figure out what the radius of this guy is.
So do you have to do like the perfect square thing?
Yeah, so I'm going to put x squared minus 24x.
You saw a pause or something?
Nope, thanks though. If I did, right, half of 24 is 12. 12 squared is 144 minus 144. Okay? And then plus y squared minus 22y. What's half of 22? 11. What's 11 squared?
132.
132?
No,
121.
Yeah, I was like,
I've already done it. I already know.
okay. So plus 121 minus 121 is equal to, on this guy here, I guess it's going to be a negative 264. Did I write that down right? Was it a negative 264? Okay. And let's just make sure that that one is written right. Okay. Question one?
Oh yeah, I was not since that's good data on my cheat sheet. So like a good example of the
This one's actually a really good one. Because it's circles, ellipse, and square root function. And just the process of being able to decode this is probably something that's helpful. Like the idea of with all these moving parts here, I have to know, and I'll put it this way, what's really weird about it is that you're solving a foci, which is a point on that ellipse, but that point that you find isn't just the foci, it's the hk, the square root function.
So you 2 for 1.
So you've got to like know a lot of things that is happening at the same time. When I find out what the square root function passes through the center of the circle, I have to now know that once I find the center of the circle, which is what I'm working on right now, that hk is just going to be a point on the square root function. So it's kind of weird that like a point in this circle is just an xy on the other guy. And it's just like, it's so much to kind of like rationalize, but I'll move these guys
Sir,
over the negatives. Yeah.
where'd you get the negative 22y? Oh, no, I see it.
Yeah, that was here right here. Yeah. So then now we're going to perfect square this stuff, right? So that gets perfect squared, that gets perfect squared, and then these two guys get pulled over to the other side. Okay, so you're technically going to say this guy becomes x minus 12 squared, y minus 11 squared is equal to, what is it? 520. So you got negative 264, and I'll say plus 144 plus 121.
It becomes 1. Yeah, you're left with it just equals 1.
Your alpha is equals 1? Okay. So then now it's just going to be x minus 12 squared plus y minus 11 squared is equal to 1. So, how is this helpful to me? This is where the arrows come into play. H is 12, K is 11. Let's go to our diagram. Does that make sense? Right here, this is 10 and 8, and the H and K I got is 12 and 11.
Yep.
Story checks out. Okay, that's something I want you to do with these guys because this is where you'll know you've screwed up. Because everything is like perfectly in place. These are easy diagrams to make, so the diagrams are usually more accurate. So you'll be able to go 12 and 11, 10 and 8, perfect. And then what's my radius? 1. So, if my HK is 12 and 11, well, let's actually take this guy, right? That's the center of the circle. So this answer right here is going to be 12 and 11. That's the xy on that square root function.
And then you just use this, you use that as a point for the square root function.
I use that as a point for the square root function.
How'd you get the radius?
So because radius, so this formula for a circle, x minus h squared plus y minus k squared is equal to r squared. So this guy's always r squared, so I'll just take the square root of it. Yeah, and then that's going to be it. It's just weird that it's 1, so it's the same answer as.
I thought it was supposed to be 1 at the end, though. No, that's
For ellipses. Yeah, that doesn't. For ellipses and hyperbolas, it's 1.
Is that a circle?
This is supposed to be a circle.
Oh, the outside. Oh, I understand.
The outside's an ellipse. The center of the circle is a point that it passes through. And so we just found out that this guy here, I'll write it in here, is 12 and 11. Okay? All right. If I start to go through this now, I rearrange this. If you were able to reason through square root function finding rule, HK is the right foci of the ellipse, that would mean that my next step on this guy here is going to be, let's go ahead and find
The right
this,
foci.
the right foci, exactly. So let's find out what C is. So let's move this guy over. Yep. Let's unplug you. Bring you over there. Don't you dare unplug. Would you stop? Okay. So now I'm going to be looking for right foci of the ellipse. Okay? So right foci, or let's just say let's find C. Find C. So if I've got x minus 10 squared over 100 plus y minus 8 squared over 64 is equal to 1. What of that do I actually need? That's the ellipse. I'm looking for the value of c. Let's just start to write things down as we know those. The a is 10, the b is 8, the c is
That's all you need.
unknown.
So you need-
That's what I need to find right there.
Yeah, but you
So-
can just do c squared equals a squared minus b squared, right?
C squared is equal to a squared minus b squared. You should have that because it's horizontal. That's going to be the formula that we use. Or you can always say, I know that the hypotenuse of horizontals is a, and then I know it's always big minus small. So it's just basically going to be c squared is equal to 100 minus 64. Okay? So what do I have?
36.
C squared is equal to 36,
So
so C is equal to 6. Now, how does that apply to this guy over here? Let's actually go back to the diagram. Okay?
So you have your distance from your center to your foci. So you can just
So that's where these guys are different, right? You know that the center of it is 10 and 8. So that means that the foci, in this case,
it's 4 and 8.
it's not 6 and 0.
It's 4 and 8, right?
Well, if I went this way, right?
Oh, it'd be 16 and 8, right? Okay.
So I'm just basically going to take the foci here, and it's just going to be, I know that this distance, let's use a different color here. We found out that C was 6, so that means this distance here is 6, meaning 10 plus 6. The K didn't change. The K didn't change, so it would be 16 and 8. And that's all it's going to be. So I found C just so I could go to this diagram and figure that out there now. So now I can write down in here that the HK of this guy here is 16 and 8. Because I was able to find that doing what I just did. There we go. So, okay, I have that square root function. I now have everything I need for this square root function. So in fact, let's just do that right there. We've got some space for it. If I know it's a square root function, and I know from the diagram I need the rule of this guy, y is equal to a square root of plus minus x minus h plus k. The reason why I put that plus minus in there this time. This guy is tricky.
Because if you just did the 12 and 16, it's a negative, and you can't
Square
square
root of
that.
negative, and you're like, that doesn't make sense, that's weird. So actually, let's do that. Let's do what you just said. I want to find a right now. I'm going to plug in my h and my k and my x and my y. So this was my x and my y. The a is unknown. The x was 12 minus 16. Okay? And then plus 8. Okay? So the HK of this guy is what I found there. Just as a point of clarification, I made sure to rewrite this guy in here that the right foci of the ellipse was the HK of the square root function. The center of the circle was just an XY on that guy. So I didn't have to think about it afterwards. What you're going to screw up is you're going to still have it written as like the HK of the circle, and then forget that that is actually just the actual point that I'm going to use. What I've seen people do with this question before is they take the 12 and the 11 and they just sub it in as the actual vertex of this guy because they didn't label things properly. Okay? Now I know my chalkboard ramblings are a little bit odd, but I would highly suggest when you approach stuff like this to just do things collectively, like circle, everything related to circle. Square root function, everything related to square root function, everything labeled properly. So then now, you just said it. Let's work through this. 11 is equal to a square root negative 4. Wait a minute. What did I do wrong in this case? Let's look back at the diagram. What did I do wrong here? If I look back at the diagram here, I'm just trying to find A, and I can't because it breaks. I'm going to take 5 minutes and go back and go, well, was this guy right? Was this guy right? Yeah, everything seems fine. So what can I do? What can I assume for my square root function? I'd go back to my notes and recall that square root functions, right? They can face this way, they can face this way, they can face this way, and they can face this way. And the only rare aspect of these guys that is super tough is that if they give you a diagram that has one facing this way or facing this way, you have to manually, when I put this in here now, let me just tilt that for a second. And then bring it over. Okay. You'll have to manually put it in now. 11 is equal to A. Well, it's facing left. What deals with square root functions facing left and right? It's the value of B. So that's going to make this negative 12 minus 16 plus 8. How does that change things? That changes things a ton now, right? Negative 4, now this guy is going to work. 11 is equal to A, square root of 4 plus 8. Bring that over there, right? I'm going to have subtracting 8, 3 is equal to A times 2. And then we will divide by 2. Our A will be equal to 1.5. Okay? So I now have the rule of the square root function. Okay? I have the rule of the square root function. Don't be blinking.
There's no battery in this one. There's a blinker, why don't you use it?
Whose is that one? There. Okay, continuing on. If I come back to this guy here really quick for a second. Let's just take a look at this guy here, ladies and gentlemen. No? Okay.
What are you talking about?
We just found out that the rule of this guy is now, the A is 1.5. Okay, I have the rule of this function. I knew that I needed the rule so that I could plug in that 8.75 to get an x value. I now also know as soon as I get that x value, 3 times the radius, which was 1, away from that is going to be the x of p, and I'll be able to plug that in now. So what is the rule of this guy? So the rule of this guy, so square root function, y is equal to 1.5 square root minus x minus 16 plus 8. Okay?
Wait, so where'd you pull this up from?
So where I got this from was
H and K.
I plugged everything in to the square root function and got a is 1.5.
Okay.
So the h and k don't change.
Well, okay, so you just plug the A in.
So I now just when I found the a, I now have the rule because I have a, b, h, k. Right? So I can even list that out too, right? Like once I get all of those parameters, then I know I'm basically set to continue. And then I can double check my work too, right? Because it faced this way here. So yes, my b was negative, but my a was positive. So that story checks out based on my diagram right there. So I can safely assume that I have the right answer right now.
So that's just the rule of it.
Mm-hmm. So then what we're trying to find out is, for this rule, when y is 8.75, what is the x value? So we're going to plug in y is 8.75. Let's get another piece of chalk.
Get a cool color.
This question is so
Blue.
It's so long, yeah.
so long.
8.75 is equal to 1.5 negative x minus 16 plus 8. Okay, so now that I've got this guy right here, okay, Gents, eyeballs up here. I'm gonna go ahead and just try and remember, solving for x is the toughest because I'm gonna try and work my way in towards it, okay? These ones are a little easier because there's only one answer, but I'm gonna work my way in towards it. So,
8 over.
bring the 8 over,
Divided by 1.7.
0.75, 1.5, negative x minus 16.
So would you divide 0.75 divided by 1.5? And then
Yep.
You're so smart, eh?
So you would have 3/4 divided by 3 over 2. So 6 over,
then you do square root.
what is it?
0.5.
0.5.
So trying to act cool, just.
Well, because I was just, that's 3 over 4, that's 3 over 2.
It's
You
half
divi-
of it.
Yeah.
Half of it.
Okay.
Then you square.
All right, it's also half of that guy, so yeah.
So you square now.
So then now, negative x minus 16. So you're right, at this stage, let's square both sides.
To get rid of the.
So would that be 0.25?
0.25. 0.25 is equal to now negative x minus 16. So square root functions have one answer. They only have one answer on these guys here. So 0.25 is equal to negative x plus 16. Bring that guy over right there. We're going to now have
Negative 15.75.
negative 15.75 is equal to negative x. So my x is equal to 1575. So that means 1575, 875. That's the point that I just found.
Yes.
Okay? In terms of how this fits in the diagram, I'm not going to go back over to it, but we had this square root function. Okay? We knew it passed through this circle. This is the boundary of the ellipse. This is point P, what we're looking for. We don't know x, we don't know y for that guy. Okay? So, just freeze for a sec.
Are we done? Look at this lab.
I drew a portion of the diagram here. Okay, so what I want to point out to you, so 1575, 875, that's what we just found out. We now know that the point right here is 1575, 8.75. That was this point right there. We're looking for point P right here. It's on the ellipse, okay? I'm just drawing a portion of the diagram here right now. This was the square root function. That's the circle. That's the point we just found. That's the point we're looking for. The other component of this that you were given was that this distance along here was 3r. Well, I know that my radius was equal to 1 for this circle, so 3r is just equal to 3. So now what do you know about point P? It's just 1875.
Pushing through.
Okay? So if that's 1875, I now have to plug that guy in to the original equation I found at the outset.
The numbers are surprisingly nice until the end, and then it just got screwed up.
Yeah, and is equal to 1. So you're going to plug that in and go ahead and solve for it. I'm going to give you 10 minutes to solve this on your own, and then I'll come back and solve this guy with you.
Perf.
So as just a quick little piece of advice for you as you approach these guys here, what I might do if you don't like